Good afternoon, this is Ms. Parks. Today we're going to talk about the unit circle, and the unit circle is used a lot in trigonometry and upper level math classes. And we're just going to learn all of the parts of this. You don't have to memorize. I'm going to show you how to figure them out without memorization and to actually understand it. Because if you understand how everything is related, honestly, if you know this quadrant, you should know most of the quadrants, but we'll talk about that in a minute. So first, let me explain why it's called a unit circle. So whenever you have an XY axis, let me draw this out, make it a little bit smaller. Let me make sure that these are all lined up, or it's pretty close. And these would be your numbers here. You would have 1, 2, 3, 4, 1, 2, 3, and then -1, -2, -1, -2, and so on. If you have this is considered a unit circle, okay? And the reason it's considered a unit circle is because it has a radius of 1 unit, okay? A radius of 1 unit. So that means that this point right here is 1, 0. This point right here is 0, 1. These are XY points, by the way. This point right here is -1, 0. And this point right here is 0, -1. Now, if the unit circle, this has a radius equal to 1, then remember the radius and the radian are going to equal the same thing, but you're never going to have an x or a y that's going to be more than 1 because 1 is the greatest number here. Okay, we're going to talk about that in the unit circle, but this is why it's called a unit circle. It has a radius equal to 1, and so that's a radius everywhere. And we'll talk about the angles, the radians, and we'll actually talk about these XY points that are on the outside. Okay, here we go. So the first thing I would like you guys to do is fill in the angles. We've talked about the angles before. Fill in all of the angles that you know. We'll start there. And these little circles are degree signs, so you don't have to write the degree sign in. They'll be there for you. All right, so go ahead and do them all first. Come back and check. I'm going to fill them in as well. Okay, 0, 30, 45, 60. We have 90 degrees, 120. They're all separated by 90 except for the one in between these two is separated by 15. It's exactly in the middle. So 150. This is 180. That shouldn't be a surprise. We add 30. Then we add 15. Then we add 15 again. So I just add 30 to the previous one. This one is 270 degrees. 300 degrees. 315. And 330. Okay? So we have those done. Next, I want you to fill in the radians. And we talked about this before, and I'm going to remind you again here that this is 0 radians. This is pi. Okay? This is pi over 2, and this is 3 pi over 2. Now, for the rest of them, just do the denominators. And the denominators are 6, 4, 3, and then 2. But you have to start at the x-axis. 6, 4, 3, and then 2. 6, 4, 3. The denominator here is 2. And then 6, 4, 3, and then 2. So we're doing the denominators for all of the fractions. Now, in the first quadrant, we're going to put pi at the top of all of these. So pi. Simple enough. Pi at the top of each one. Super easy. Now, at 180, that's pi. So remember, in the second quadrant, we need to have a fraction that's as close to 1 pi as we can get. So this will be 5 pi over 6, 3 pi over 4, and 2 pi over 3. So basically the top number is 1 less than the bottom number because that's as close as we can get to 1. Here's a good thing to look at also. 30 is pi over 6. You can actually do all of these as multiples of 30 if you want to, but because 150 is 5 times as big as 30, then the radians are 5 times as big as well. Okay, and if you want to know what the bottom number is, you just divide 30 into 180. That'll give you a 6. Okay, so this is 1/6, so this has to be 5/6 pi. All right, let's keep going. In the third quadrant, we're going to be just a little bit bigger than 1. So a little bit bigger than 1 is 1 more. It'll be 1 more than the denominator. So this is going to be 7 pi over 6, 5 pi over 4, and 4 pi over 3. And again, it's 1 more than the bottom part because we're just a little bit. So this is 1, and this is 1 1/6. Okay, this is 1, this is 1 1/4, and then this is 1, and this is 1 1/3. Now, when we get all the way around the circle, that's going to be 2 pi, and I actually should have written 360 degrees here. So for the radians that are in pink, we're almost to 2 pi, so this number has to be as close to 2 as we can. So basically what you're going to do is double that number and subtract 1. Because if that was 12 pi over 6, it would equal 2 pi. So we're 1 less than that. And then same thing here, if that's 30, this is 11 times bigger than 30. Okay, 30 times 11 is 330. So pi over 6 times 11 is 11 pi over 6. Okay, so double the bottom and subtract 1. Double the bottom part and subtract 1. Half of your unit circle is now done. Okay, so you have all of the angles on here, and you have all of the radians on here as well. Now we're going to do these numbers, and we talked about already the edge numbers. We already know what these are because they have a radius of 1. And since they have a radius of 1, I already know the points that are on the x-axis and the y-axis. So let's go ahead and fill those in. All right, so to fill those in, let me see what color I could use here that stands out. I'm just going to go ahead and use red. So this point right here is 1, 0. This point at the top is 0, 1. So x is 0, y is 1. This point, the x is -1, y is 0. At the bottom, x is 0 and y is -1 at this point. Now to do these. In order to do these, I want you to remember the 30, 60, 90 triangles and the 45, 45, 90 triangles that we just finished doing, okay? So for all of these, I'm going to make the radius 1. Or the hypotenuse 1, I should say, okay? These are all right angles. Right triangles, excuse me. And let me give you the angles. So this one is 30. This one is 45. And this one is 60. Now, what I would like you to do is fill in the missing sides using the special right triangles numbers that we learned in section 1. So go ahead and fill those in, please. Don't use decimals. While you're filling that in, I'm actually going to draw in these colors into this picture. All right. So if this is a 30, 60, 90 triangle, which it is, and the hypotenuse is 1, then the short leg has to be half of that. And the long leg has to be radical 3 times the short leg. That's this triangle. So to get to this point, I need to go on the x. This is the long leg. Radical 3 over 2. And for the y, I'm going up 1/2. And if you kind of look right here, this is about halfway to 1. No, it's exactly halfway to 1, to be honest. Okay, so this is the x value. And so for the x value, you're going to have radical 3 over 2. And for the y value, you're going to have 1/2. And that's how we get to this point. Just like this point right here, the x is 1 and the y is 0. All right, let's go ahead and go to, and this is 30 degrees right here. Okay, 30 degrees. That's why we're at 30. Now, for the middle one, and if you guys have highlighters, highlighters are good to use here. All right, so this is the 45, 45, 90. And remember, in order to get to the legs, you have to take half of this and multiply by radical 2, or divide that by radical 2. So what you have is radical 2 over 2 for both of them. So both the x and the y to get to this point are radical 2 over 2. Okay, those are the legs. The x and the y are exactly the same length. Now let's do the 60-degree reference angle. So for the 60-degree, what we have here. All right, let's try this again. All right, so for the 60-degree triangle at the bottom, it's exactly like the first one, except for the short leg is now on the x, and the long leg is on the y. So basically, you have exactly the same answers as your blue triangle, except for the short leg, 1/2, and then the long leg, radical 3 over 2. So that covers the xy points in the first quadrant. However, it also covers the xy points in every other quadrant. And the reason why is because all of the 30-degree reference angles, and let me try to make that a straight line because that would be better. All of these have exactly the same x and y, okay? They all have a long x value and a short y value, okay? They all have a long x and a short y. And so if you wanted to extend this out, the x part is long, the y part is short. X part is long, y part is short, x part is long, y part is short. However, the only difference is that they have different signs. Because I'm in the second quadrant, I have to go negative on the x, so negative radical 3 over 2, but I'm still going positive on the y-axis. So long, middle, short. Long, radical 3 over 2, middle, radical 2 over 2, short, 1/2. These are the only numbers that you're going to use in the first, second, third, and fourth quadrant for x and y. That's it. All of these that are close to the x-axis will have these numbers. Okay? Exactly the same numbers. The only difference is whatever quadrant you're in will determine when the signs are for your x and y. So this one, long x, positive. Short y value, negative. Quadrant 3, negative x, that's long. Negative y, that's short. So if you look at all the highlighted ones, they're exactly the same. And the same thing's going to happen for these. So see if you can fill in the rest of these. Based on what we just finished doing. All right, hopefully you filled those in. I'm going to fill in the rest of them right now. So this is negative radical 2 over 2, positive radical 2 over 2, negative radical 2 over 2, negative radical 2 over 2, and then positive radical 2 over 2, negative radical 2 over 2. And then for the last one, I'm going to write in black even though it's highlighted in green. Negative 1/2, positive radical 3 over 2, negative 1/2, negative radical 3 over 2, and positive 1/2, negative radical 3 over 2. And I'm going to finish up by drawing in the rest of these lines. You can put them there or not. If you think that they're in the way, then you don't need to draw them. All right, so again, I'm just drawing these in. You don't have to draw them. You can if you want to. All right, so hopefully you can see where in the green triangles, you have a short x and a long y. In the blue triangles, you have a long x and a short y. And then in the 45-degree reference angles, I know we haven't really talked about, but how far away a reference angle is, how far away it is from x. Then those all have the same legs because they're 45, 45, 90 triangles at the 45, here at the 135, 180, 315, not 180, excuse me. Anyway, at the 45-degree reference angles. Okay, now that covers almost everything. There is a little trick, a hand trick on how to remember these. I always remember that the y's get taller and taller and taller. So if you look at the y values, it goes 1 over 2, 2 over 2, 3 over 2. And this is actually radical 4 over 2. So the y values, as you're going up, get bigger and bigger and bigger and bigger. And same thing on this side. The y values go up, 1 over 2, 2 over 2, 3 over 2. The x values are the opposite. Now, what we're going to be doing later, which may be a little bit too much right now, is that your x and y are cosine theta and sine theta. So let's just look at this right here. That means that cosine of 300 is equal to that number. And sine of 300 is equal to that number. Okay, if you look at this right here, sine of 30 is 1/2 because it's the y value. Cosine of 30 is radical 3/2 because it's the x value. So sine and cosine are whatever the x and y value are at that angle. Tangent is the slope. So tangent, we haven't added that in. I'm going to put it on the outside. Okay? And again, I know this is a lot. And I don't expect you to know everything all at once. We're gonna practice this, okay? So tangent is the slope of this line. So there's 3 answers for tangent. Okay, or actually there's from highest to lowest, we go 0. Then we have radical 3/3. Then we have 1. Then we have the square root of 3, and then we have undefined. So 0, because that's the slope of this line right here. Okay, tangent, slope. So this is 0. Then tangent here is positive because it's the slope of this line that goes up. And it's a fraction, radical 3/3, radical 3/3. Then here on the red one, the slope, if the x and the y are the same, then the slope is 1. So the slope of the red lines are 1. That's positive 1. And then for the steep line, the slope is radical 3. Remember, it's rise over run. So if you wanted to, you could just do rise over run. I always remember the flat slope is the fraction. They start with an F. And then the line that goes straight up and down doesn't have a slope. It's undefined. The other ones that go downward are the same answers, but they're negative. Okay, so negative radical 3/3, negative 1, and negative radical 3. So if I said, oh, what's tangent of 45? You would say 1, because that's the slope of that line. Okay, so it's a lot. We're going to practice more and more and more so you have a better idea of where these numbers come from. I will send out some blank unit circles so you can practice, and then hopefully you'll get the idea as we go along.